This is Phil Coatman with a tutorial on 3 key embedded software process metrics. In this tutorial, we'll discuss 3 key metrics that we've found are useful in determining whether an embedded software development process is healthy or sick. 3 signs of a sick software development process are the number of labor hours spent doing development, including design and implementation, exceeds the amount of time spent doing validation and testing. The developers are producing too many lines of code per hour. And peer reviews find fewer than half of all the bugs discovered. At a high level, the following key metrics tend to predict healthy embedded software development projects. About 2 hours of effort are spent on validation for every hour of effort spent on code development. That generally implies a tester-to-developer headcount ratio of about 1:1. Typically, you expect to see a productivity of between 1 and 2 lines of code per hour, perhaps 3 lines, for solid embedded software. This includes the entire process from initial requirements through acceptance test. Finally, peer reviews should be finding more than half of all the defects found during the product's life cycle. Let's start with the topic of design-to-test effort ratio. Creating software is much more than just writing code. Here is a graphic of the V model that is commonly used for embedded software development. The left-hand side is in general design activity and includes requirements, architecture, design, and implementation, which is the part where you actually write the code. The activities on the left-hand side are typically done by designers. The right-hand side is in general testing activity and includes module test, integration test, and validation test. In general, the activities on the right-hand side are typically done by testers. Note that there is some overlap on module test, often called unit test. Designers often write the unit tests, but it's also common for testers to write at least some of the unit tests, especially for regression testing of bug fixes. Not shown explicitly in this picture is the peer review process, which should be happening for every box in the diagram, but is especially critical for the design side of the V. The big question that is often asked is, given a certain number of developers, how many testers should you have? Numbers for this tester-to-developer ratio vary considerably and are specific to a particular organization and the type of software being developed. Nonetheless, there are some general trends that are apparent. Web development and other everyday software often has a ratio of 1 tester to 5 or 10 developers. Microsoft and a number of other companies say that they have 1 tester for every developer. Aerospace companies have said that they might have 4 or 5 testers for every developer, so that's basically an inverted ratio compared to the everyday desktop software developers. Based on extensive interactions with embedded system companies that make highly reliable software, we have found that it is common to have a tester-to-developer ratio of about 1 tester for every 1 developer. The effort tends to divide up in the following way. About 1/4 of the labor hours charged to a project are spent by developers doing requirements, architecture, design, and implementation. Another 1/4 of the labor hours gets spent by developers doing peer reviews, unit tests, tool development, and bug fixes. About 45% of the effort is spent by testers doing various types of testing, creating testing infrastructure, and generating bug reports. The last 5% is spent on software process, including creation, improvement, training, and auditing, often known as either SQA for Software Quality Assurance or PPQA standing for Process and Product Quality Assurance. From a headcount point of view, let's consider a 20-person project. In this example, the headcount breakdown works out to be 10 developers, 9 testers, and 1 SQA/PPQA support person. That's about half developer staffing and half validation staffing, depending on how you like to count things. From an effort point of view, you can see that only about 25% of the total effort is actually spent doing the primary development, and even that is spread across requirements, architecture, design, and writing the code. In healthy software projects, it is common to see only a handful of the percent of the total effort be writing the lines of code, and the rest of the effort spent making sure that the right code is being written and the code is being written right. Even understanding all the things that have to be done to create good software, it is still often a surprise to see that software productivity is usually only 1 or 2 lines of finished code per labor hour for a high-quality embedded software project. This includes all labor, from requirements all the way through system test. I have seen perhaps 3 lines of code per hour in Agile method projects, but often that speed comes at the cost of an increased risk of defect escapes because the team has traded off process rigor for speed. Keeping in mind that we're talking about total labor all the way through product test, if your team is shipping software having spent significantly less time than 1 or 2 lines or maybe 3 lines of code per hour, probably you've been cutting some corners. Perhaps you have weak or missing requirements. Perhaps you've skipped the design step. Or perhaps you've skimped on peer reviews. Or maybe you've skipped all the testing except the final functional system test. Those things might appear to help you go faster, but many times you make up for it by having to spend longer in system test, or even worse, have bug escapes into fielded products. In our experience, if you're going faster than 1 or 2 lines of code per hour, you're taking an increased risk of having bugs get out. It's always possible to get lucky, but in general, cutting corners catches up with you in the long run. If you do the math, this means your code can easily cost the company $25 to $75 per line of source code. The actual number depends on your location and also factors such as whether your accounting system charges overhead on your development staff. Again, keep in mind this is the entire cost of development from requirements all the way through acceptance test. Maintenance can cost even more, perhaps significantly more if you end up having a product recall because of defect escapes. Given how expensive software is, it's important to find cost-effective ways to prevent defects from reaching testing or getting into the field. Good peer reviews find half to 2/3 or sometimes even more of all the defects in your software. If you're finding less than about half the defects in your peer reviews, that means they're broken. Teams commonly say that they don't have time for peer reviews. So let's do some math and see if that makes sense. Peer reviews cover 100 to 200 lines of code per meeting hour. Including some time for preparation, let's call it 100 lines of code per hour total. Assuming that you have 3 reviewers all spending that hour to look at 100 lines of code, that's about 33 lines of code per person hour of labor. That sounds pretty cheap at only 2 minutes per line. If you consider that a fast team is writing 2 lines of code per hour, spending 4 minutes out of that hour on peer review is less than 7% of the total project cost. That seems pretty cheap for finding half the bugs. Requirements and design should also be reviewed, so that might get you up to about 10% of total project cost. But again, the reviews are extremely effective at finding bugs, and each bug you find is less effort spent in dealing with bugs that crop up during testing. So ask yourself, are your peer reviews actually finding half or more of all your bugs? If they're not, perhaps it's because you're bunching your peer reviews up at the end of the project and burning out your reviewers instead of spreading out the reviews to keep the workload sane. Or perhaps there's a problem with your review culture, such as team members who are afraid to criticize others due to an adversarial climate in the review meetings. Fixing these problems will give you a huge benefit. Summing up, here are the best practices for key embedded software metrics. you should be spending about 2 hours of effort on validation for each hour you spend on development. As we discussed, that usually results in a headcount ratio of about 1 tester for each developer. The headcount ratio might change depending on how you divide responsibilities, but what's important is that the ratio of effort in hours should be about 2 hours of validation for each hour of development. In a high-quality embedded development project, about 5% of the time is spent on maintaining, teaching, and auditing the software process. That means that with a 20-person group, you'd normally expect to see about 10 developers, 9 testers, and 1 SQA PPQA member. Code productivity should be about 1 or 2 lines, perhaps 3 lines per hour across the entire team's effort. Above about 3 lines of code per hour, you often see software quality problems because too many corners have been cut to meet a deadline that's too aggressive. Elevated code productivity metrics are not actually something to brag about, but rather a sign that probably something's wrong and probably you're spending a lot of time chasing down bugs in system test and ultimately shipping buggy software. Peer reviews should be finding half or more of your defects and should be costing about 5 to 10% of the total project cost. If you meet all 3 of these metric targets, from what we've seen, chances are good that your project is generally healthy. If you meet none of these metric targets, you can probably get significant improvements in software quality at about the same cost simply by modifying your development practices as indicated by these metrics. Anytime you take a measurement of a team's performance, there are pitfalls. First of all, you should only use metrics that provide actual value and are not too disruptive to your development process. We found that these 3 metrics are relatively simple and give a lot of insight. You might want to add some other metrics, but we advise you not to go crazy with metrics. Second, anytime you use a metric, there's the risk that people will game the metric without actually improving the underlying process. The metrics we've described are best used in initially evaluating an existing software process. Modifying the process to improve the metrics should be done to actually improve software quality and not simply game the metrics. Usually that means accomplishing change in the underlying culture and the underlying process.